Hi all, hope you are fine and safe at your home. Today we are going to discuss about one of the important topic, which is prime factorization. This prime factorization is important because this concept can be used for finding LCM and HCM. So we shall make a better understanding of what is prime factorization and how we can do the prime factorization of a number so that it will be useful in coming topics. Okay, so by definition, prime factorization of a number means expressing it as a product of its prime factors. So actually, what is mean by factorization? Factorization simply means writing the number as a product of its factors. Prime factorization means we are writing the number as a product of its factors, but all those factors must be prime factors. So prime factorization is expressing the number as a product of its prime factors. So now let us check how we can do the prime factorization of a number. In order to do the prime factorization of a number, there are two methods. Basically, there are two methods we can use. One is factor tree method and the other is the continuous division method. So let us begin with the factor tree method by which we can find the prime factorization. So here we are going to discuss about factor tree method. So let's take an example. Let's consider the number 48. And now we are going to do the prime factorization of this number 48. In order to do the prime factorization of number 48 by factor tree method, as this number 48 is a composite number, we will begin with putting this 48 in a rectangle. Now what we do is we just split this 48 into different factorizations, and upon those factorizations, if there is a prime number comes, then we will round it, and if there are composite numbers, we will put it again in rectangles, and as rectangles represent the composite numbers, it can be further factorized, and we will continue this process until we get all the factors as prime numbers. So let us check how this can be done. You can see 48 is an even number. So the best and the simplest factorization that we can do for 48 will be 2 into 24. Just the half of 48, which will be 24. So 2 into 24 will be 48. Upon which this 2 is a prime number. Which are the list of prime numbers? 2, 3, 5, 7, 11, 13, etc. Like that the list of prime numbers goes. So you can see 2 is a prime number, so I just rounded it. Now here the next number in the factorization, which is 24, is a composite number, and that's why I put it in a rectangle. Now this has to be further factorized. Again you can see this is an even number, so definitely it can also be factorized as 2 into something. Can you tell me 2 into which will gives you 24? Just the half of 24, which is 12. Now this 2 is prime number, which is rounded, and this 12 is composite number, which has to be put in a rectangle. Now further we are continuing with this composite number. So this 12 can be split up into 2 into 6. 2 is prime rounded and 6 is composite, which is put in rectangle. Now further you can divide this 6. It can be written like 2 into 3. Now you can see both these 2 and 3 are prime numbers. So definitely they can be rounded. As there are no more further composite numbers we can stop our factorization process. Now we are going to write down the prime factorization for this 48, and it can be done by taking the product of all the prime factors. And in order to identify the prime factors in a faster manner, we have already rounded them. So we just want to write the product of all these numbers inside the rounds, inside the circle, so that we will get the prime factorization of 48. So tell me how it would become. 2 into 2 into 2 into 2 into 3. That will be the prime factorization for 48. So what we have done is we just used the factor tree method for finding the prime factorization of a number. Hope you all understood. Now I told you there is one more method by which we can find the prime factorization, and it is known as continuous division method. So let's take an example and do the prime factorization by using continuous division method. Just listen all of you. Now we are going to do the prime factorization by using continuous division method. So let's take an example. Suppose we got a number 840 and we are going to do the prime factorization of this number 840, and we are choosing the continuous division method. The reason why we choose continuous division method here is actually this 840 is a bigger number. So when we do the prime factorization using factor tree, it would require a lot of space and it may be difficult too. Okay, so that's why we prefer continuous division method, as our number is a little bit bigger one. Okay, and in continuous division method, first of all we will be writing the number just like 840 as itself. Now you can put a cross like this. We are going to divide this number, and this division is vertically downwards we are doing. Usually we do the division just like this. 840 we will write here and we will cross like this, and quotient will be written on the top. But we need to do the continuous division. Continuous division means our division will be continued many times, and we will continue our division with the quotient obtained as the new dividend, and that's why we prefer the quotient to write just below like that. Okay, so first of all we got the number 840 as the dividend. Now we want the divisor. Actually we would divide this number 840 by the possible prime numbers. So we shall begin with the smallest prime number. That will be the better thing. So let us check whether this 840 is divisible by 2 or not. Absolutely yes, because 840 is an even number. So we will begin with the smallest prime number 2, by which we will divide this 840, and we have the idea that when 840 is divided by 2, the answer will be just the half, 420. Now again we will put cross like this. because we are doing continuous division. We need to do many number of divisions, and the quotient obtained will be our next dividend. Okay, again you need to confirm which is the divisor we need to use. If it is even number, again definitely you can use the smallest prime number 2 itself as the divisor. So when you divide this 420 by the number 2, we have the idea that the half of 420, which will be 210. Again it is an even number, so definitely we can continue the division by the prime number 2 itself. Now when 210 is divided by 2, we will get the half of this 210, which is going to be 105. Now you can see this 105, it is an odd number. So now we cannot continue the division by the prime number 2. So the division by this prime number 2 is over here in this case. Now once the division by prime number 2 is over, we need to check whether this number obtained is divisible by 3 or not. In the previous section on our chapter, same chapter, in the previous section we discussed about the divisibility by 3. In order to check the divisibility by 3, we just want to add these digits. So you can see 1 plus 0 plus 5, it will be 6. And obviously 6 is a multiple of 3. So definitely this 105 can be divisible by 3. So we are going on with the continuous division, but this time our divisor is changed from 2 to 3. So I just wrote 3 here. Now you tell me how many times 3 occurs in 105. Inside 10, actually 3 occurs. Now there will be one remainder. 3 3s are 9. Here it is 10. So one remainder will be there, and that 1 and 5 has to be considered together, so that it will become 15. And in 15 there are how many 3s? There are 5 3s. So you shall write 5 here. So now you got 35 as the quotient. Can you tell me whether we can divide this 35 by the number 3 or not? Just add the digits. 3 plus 5, it is 8. 8 is not divisible by 3. So definitely 35 also will not be divisible by 3. So definitely we will go to the next prime number, and it is 5. You can say 35 is obviously divisible by 5. So you will put 5 as the next divisor. Now you tell me how many times 5 occurs in 35. Yes, 7 5s are 35. So definitely here we obtain 7 as the quotient. Now this 7 is not further exactly divisible by 5. So we will check for the next prime number, and we got lucky. 7 is the next prime number, and we got 7 here itself. So definitely we can do the division by 7. And 7, in 7 there are exactly 1 7. So finally you got 1 at the bottom. So you should have to continue this continuous division until you get 1 at the bottom. So now we got 1 at the bottom. So we shall stop our division. And once you finish the continuous division, we will get the prime factorization for this 840. The prime factorization for this 840 will be the product of all these prime numbers which came as the divisors, which are found on the left side like this. Okay, so now you tell me 840 can be written as its prime factorization in the form 2 into 2 into 2 into 3 into 5 into 7. This will be the prime factorization for the number 840. So hope you all understood how this prime factorization can be done for bigger numbers by using continuous division method. So that's all about prime factorization. So what we have discussed today is what is mean by prime factorization, how we can do the prime factorization by using factor tree method and continuous division method. Hope you all understood. Then we shall see on our next class with some other topics. All of you, see you. Bye bye everyone.